Consider the sequence an from n equals 0 up to infinity. So we've got an infinite sequence here, given by an is equal to -1 to the power n. By determining the sequence of partial sums, figure out whether or not this series, adding up our particular sequence, converges or diverges. Well, let's take a closer look at our sequence. Okay, we start with 0, then a1, then a2, then a3, then a4, and so on. So let's just get a sense of these. It's -1 to the 0. Now, -1 is very nice because -1 raised to an even power, like 0, 2, or 4, is always going to be 1. -1 raised to an odd power, like 1, 3, or 5, is always -1. So we really do understand our given sequence. It goes 1, then -1, 1, then -1, 1, then -1. Just alternates like that, back and forth. Now let's take a look at our partial sums, and we should start with S0, or S0, even though you're adding up one whole term, so you might think, well, shouldn't that be S1? It doesn't really matter. Okay. You could write it as S1 and say I'm adding up one term of the sequence. I like to have my indices match, personally. Okay. So S0 is equal to A0. S1 is A0 plus A1. A0 plus A1 plus A2. Okay, but we know what these are. 1, 1 plus minus 1, 1 plus minus 1 plus 1. Okay, we'll do a few more. We'll do up to S5, probably. And it's going to go 1 plus minus 1 plus 1 plus minus 1. And let's actually work these out. So we've got 1. 1 and minus 1 is 0. 1 and minus 1 and 1 is, well, 0 plus 1. And we get a bunch of things canceling. We get 0 for S3. More things cancel, but there's a 1 left over. So we get 1 again, and then we get 0 again. Okay, so the partial sums here alternate. They go 1, then 0, then 1, then 0, then 1, then 0, then 1, then 0. Okay. How could we write this out? Well, we could sort of use piecewise notation. We might say Sn is 1 or 0, so it's 1 if n is even, and 0 if n is odd. Okay, so we've done the first thing that they asked, determine the sequence of partial sums. Okay. And then once we've determined that, we determine whether or not the series here converges or diverges. Well, what do we know about series convergence or divergence? Okay, well, our sum, which should start at 0 here, okay, converges exactly if the limit of the partial sums exists. So we have to ask ourselves, do the SNs here settle down? Does the limit exist? Well, we see the SNs are alternating between 0 and 1. They never get closer. They never settle down. And if you wanted to, you could do a formal proof of this. Okay? But they never get closer, they never settle down. The limit of the partial sums does not exist. Well, if the limit doesn't exist, then our series can't converge. It must diverge. And there we go.